Hello, class. This is going to be a recorded lecture for section 1.4, which will be the last section in chapter 1 that we go over. And this is called solving radicals. What is a radical? Well, what a radical is an equation that has, let's start by using this idea of a square root sign. And let's see if we could do a quick, hopefully theoretical review of what a square root does to a variable, and then expand it to other roots as well. So the radical, we use this term, this little square root sign, right? And the idea of a square root sign works really well when you're talking about arithmetic. But when we're talking about variables, what a square root actually is a fractional variable. So let me kind of show you a couple things here to get things started. So if you had the square root of x and you wanted to convert that to an exponent, and you will do this when you get into calculus, and we're going to talk about this a lot more in chapter 6. This would look like x to the 1/2 power. So it's kind of strange because when we have this square root, if there's no number here, it implies that it's a 2. So say like you had this, x cubed. So you could rewrite that as the 3 is on the top and that 2 goes on the bottom. So that would be x to the 3/2 power. And if you had something that looks like this with a 3 there, that implies 1/3 root, or sometimes they call it cube root. And so that would be x to the 1/3 power. And so if you have no number, like this would be x to the 5th inside here. If you have no number, remember that means the 2 goes on the bottom. And if there's a number there besides leaving it blank, which implies 2, then you put the 3 underneath to get the answer. So what do we mean when we take the square root? Well, we know when we talk about square roots of, say, the number 4, right? We could also write it 4 to the 1/2 power. So what this 2 means, that in the denominator, is that you're looking for two numbers that when you multiply it together, you get the number 4, excuse me. And so that would be 2, right? Because 2 times 2 would equal 4. And remember we talked about we can't do this, right? That would actually be 2i if we were talking about complex numbers that we just did. But remember, -2 times -2 also equals 4, right? So that's why you really can't take the square root of a negative number. But if we take it to the next level, as say like we do this, we use the number 8. And instead of doing the square root, we do the cube root. So now it looks like 8 to the 1/3 power. So what do we do with that? Well, the idea now is you're looking for 3 numbers that you multiply together to get the number 8. And they all have to be the same. So that would be 2 times 2 times 2, and that equals 8. So what happens, for example, if we did the cube root of 27? So that would be 27 to the 1/3 power. So we're looking 3 of the same numbers, and I strategically set this up so the 3's work, right? 9 times 3 is 27. But what happens when we throw a negative number in this case? So say like I asked you, what is the cube root of minus 8. Now remember, there's no real solution for a square root, but there actually is a real solution for a negative number of a cube root. Because remember, if you think about how negative numbers work. So now we're looking for a number that you multiply together 3 times that gives us the answer minus 8. And so if we took minus 2 times minus 2 times minus 2, remember we have 3 minuses here, right? So an odd number of minuses gives you a minus, and so you would get minus 8. And you see, when you go through this, if you do minus 27, you would get minus 3 times minus 3 times minus 3. And so that would also be okay. So it's kind of weird in that, you get this, well, square root, negatives don't work, but cube roots do. Well, here's something to remember. If the root is even, you can only use positive roots. Because remember, if you take an even number of negative signs and multiply them together, it always turns into positive. But when you have an odd number for a root, like a third or a fifth or a seventh, etc., then both even and odd numbers. So hopefully that gives you a little bit of background of what we're going to talk about. Because the idea here is that we are going to solve a problem where there is a square root. And I just want to point out is that if you have x, say, to the 1/2 power, which also equals square root of x, and you said to yourself, I want to get rid of the square root, or I want to get rid of the 1/2 power. And that's going to be the strategy that we're going to use for solving these equations that have roots in them. And the idea is that you'd want to square it. And remember, when you do the algebra with exponents, is that if it's an exponent to an exponent here, so you take it to a power, you multiply these two together. So this would be 2 times 1/2 times 2, and that gives us x to the 1 power, and so that is x. So when you want to get rid of a square root or a root to the 1/2 power, you square it. How would we get rid of the cube root? Well, same strategy now, but instead of squaring it, you would want to take it to the 3rd power. And so when you do that, you get 1/3 times 3, and that is x to the 1 power, and then that's just our regular old x again. So now we're going to use this kind of strategy to solve equations that have radicals in it, i.e. they have either a square root or a cube root with regards to that. So let me show you one example, and then we'll do one more. So the first example I would like to show you is square root of x minus 1 equals x minus 7. So the strategy always is, when you have these cube or radicals, is you want the radical on one side of the equation all by itself, and the all the other variables on the other side. And so you could rewrite it this way: x minus 1 to the 1/2 power equals x minus 7. So the strategy here is that you have to do the same thing to both sides of the equation, right? So you take that to the square and that to the square. And so what ends up happening? Well, 1/2 times 2 that equals 1. So on this side, you're going to get x minus 1. So what do you get on this side? Well, remember, when you square something, it looks like this, right? So let's expand that out and see what we get. You'd get x squared minus 7x minus 7x plus 49. And so you would get x squared minus 14x plus 49 over here. Okay, so now we have something that we know how to analyze. Hopefully, you feel pretty comfortable with quadratics now. So every time you see where x squared is the biggest, the idea is to bring all the variables to one side of the equal sign and have it equal to 0. And then use the quadratic formula, factor it if you see the factorization, or that's it. Don't complete the square unless you're doing circles and foci and things like that. So we'll bring the minus x over, and we'll get rid of the minus 1, and we'll bring the plus 1 over. So what we have here is x squared, and we bring over a minus x and put it with minus 14, gives us my 15x. And you bring the plus 1 over, we get plus 50 equals 0. So we're in a math class. So this one is strategically set up so it can be factored. Again, if you don't see that, don't stress about it. Just plug it into the quadratic formula and out will come some answers. Here we're going to get 2 possible solutions. And so remember, 50 equals 5 times 10, right? And remember, 15 is plus 5 and plus 10. So the strategy here would be x and x equals 0. So what do we do in this case? So in this case, because there's minus 15 here, we would want a minus in both of these, right? Because the other answer is plus 50. So minus 10 and minus 5 together gives us plus 50. And when you add those together, you get minus 50. So again, we have the 2 factors. So we have x minus 5 equals 0. So that implies x equals 5 is one possible solution. And then x minus 10 equals 0. And so another possible solution is x equals 10. So I do have to warn you that these have to be checked at the end. Sometimes you're going to end up with 2 solutions and only one of them work. Sometimes both of them will work. On a rare occasion, none of them will work. So these need to be checked to make sure everything is cool. So let's do that. So just erasing a few things there. Sorry for the silence here. Need a little space. So with regards to this, let's check the number 5 first. So that would be 5 minus 1 equals 5 minus 7. So what do we have here? Well, we have 4, so that would be square root of 4 equals minus 2. Square root of 4 is 2, so 2 equals minus 2. Does that work? No. So you see what I mean? Sometimes they'll work, sometimes they don't. So let's take a look as I erase a few of these here. Let's take a look at the number 10. Let's hope this one works. Or I picked a bad example. I want one of them to work. So we have square root of 10 minus 1 equals 10 minus 7. So this would be square root of 9 equals positive 3 now. And so 3 equals 3. Yep. So the 5 does not work. And so the only solution is x minus 10. So I'm going to stop here, and I'm going to continue on the radical lectures in the next recording.